Hi everyone. This is a talk that I've been trying to give for about a month now, but I've just had various things that have made that difficult. But I'm here today just to talk a little bit about some of the fundamentals of unit testing, because I have found that it's actually a bit of a difficult topic to research. So I'm hoping I can shed a little light based on at least my experience and what I've heard from other people just sort of across the industry, talking to people in tuples, out of tuples, and just finding out where some of the sort of common little dilemmas and mistakes come about. So just to open up at an introductory kind of a level, question of what is a unit test is going to come up. But first, I'll just point out that unit testing is one part of a strategy of automated testing. And it's one that's really close to the developers. So it probably means a lot for them. But it's also useful for everyone else to know what is and isn't covered and sort of what the characteristics of a good test are. To make sure you're not trying to solve a problem with the wrong tools. So this here is a picture I've taken from Martin Fowler's blog. His name some of you might recognize. Basically he's just a person who has a lot of experience and talks a lot at length on different things about structuring software and the like. You can find different variations of this image on a whole heap of different sites, including like Google's testing blog, but I just like this one because it's quite simple. It points out that the big thing about unit tests, as you can see at the bottom, you kind of want them to make up the bulk of what you do and make up the foundation of them. They're fast and they're cheap, but they have their own downsides, which means that you also need your service and UI tests to be able to actually make sure that your application works across the board in an automated fashion. But yeah, it's foundational to an effective automated testing strategy, I think, is the main point here. So also just, by the way, if anyone has questions, you'll probably notice at the top of the screen, there's a link where you can provide a Q&A. I will attend to those questions at the end. But now, for now, what is a unit test? So turns out that actually just trying to Google this and get an answer, what is a unit test, is actually not that easy. There's a whole bunch of different people that have slightly different tangents on what they consider fundamental to a unit test and what isn't. So I picked a couple of definitions to start with. So this one is from a website called Art of Unit Testing, which hopefully means they know what they're talking about, but it is the internet. A unit test is an automated piece of code that invokes a unit of work in the system and then checks a single assumption about the behavior of that unit of work. Apologies, I don't remember whether the emphasis was mine or not. I'm just going to assume it is mine at this point in time. Martin Fowler, again. Despite the variations, there are some common elements. Unit tests are low level, are written by the developers themselves using their regular tools, and are expected to be significantly faster than other tests. Some Stack Overflow answers on it. So there's the question was, what is unit testing and how do you do it? Unit testing involves breaking your program into pieces and subjecting each piece to a series of tests. Another answer was, unit testing simply verifies that individual units of code, mostly functions, work as expected. So there's a few different variations of the definitions. They're not everyone fully agrees on it, but there are a number of multiple common concepts that you can basically hear through every definition I've read. So there's a limited scope. So it's talking about, say, a unit of work or a class or a method, something small that doesn't have a lot of variations to the way it's used. They're developer driven. So this isn't like a QA or a BA writes the specifications and says this is how it should work. This is more a case of verifying that the code behaves correctly behind the scenes. They're concise and specific. So you verify specific conditions of the result in a controlled manner. You don't kind of try everything. You don't simulate everything a user could be doing. It's more a case of make sure that if I do this, I get this result in almost in a mathematical fashion. And so I've prepared some examples of ways that you can, some of these are ways I've seen unit tests written. Some of them are perhaps slightly fictitious examples, but I've tried to come up with a few different ways in which you can write that you can improve tests or try and make sure that they're more fit for purpose, I guess. So something I've noticed is sometimes people are a little bit overzealous about trying to make sure that the test covers all specific scenarios. All code snippets are in Ruby, by the way. That's kind of deliberate because I'm pretty sure no one here really understands Ruby, so you hopefully don't focus on bad coding quality. For the purpose of the test here, though, it says that, all right, I'm going to test at the age logic, like say it's a gambling site and people under the age of 18 can't join. So the test says all ages before the age of 13 should return false. Oh, sorry, no, not gambling, like US COPPA, the child protection online laws. So anyone who's less than 13 can't sign up. Just, no, banned, not allowed. Anyone after the age of 12 should be allowed to sign up. Now, the main thing here is this test runs by testing the values 0 to 12. Cool, you can't sign up if you're in that age group. And then it tests the ages 13 to 1,000,000 to make sure that all of them say that, yes, you can sign up. I kind of think that's almost a definition of overkill, because generally you don't have to worry about users being 1,000,000 years old, at least not at the moment. Perhaps going forward that may change a little bit, but it does definitely seem like excessive use, treatment, or action. So presumably, if a legal age is a simple definition of a person being over the age of 12, their legal age, you could use a simpler test in this scenario. You really don't need to test all of those values, but you do need to make sure you have a good range of being reasonably certain that it's not just doing something really weird behind the scenes. So something a little bit simpler, pick a few different examples of ages that should succeed and ones that shouldn't, particularly making sure you're aiming for the bounds. So for example, 0 and 12, and then 13 and anything above that. Those are different values that you can at least make sure that, you know, someone doesn't accidentally put a less than or equal to when they meant a less than, or just something simple like that. But at the same time, that's a lot simpler and also can be a little less confusing for other developers in some scenarios. So that's really small. What's better about this? This is approximately 200 times faster than the first example when I tried it based on my machine. Not very scientific benchmarking, but still. It still checks the edge cases. So 0, 12, 13, we all can still verify that those work correctly. But it also checks a few other cases to make sure that other logic works as well. You know, someone doesn't put some weird knot there that makes every other case fail. So some important notes, I think, that come out of this is test for how complicated the unit is. Presumably, this logic is as simple as, is the number bigger than this? It doesn't need you to basically bring like a whole, you know, you don't have to bring a whole suite of tests, a whole lot of force to bear to try and say, is this all correct? If it's a simple mathematical check and you can be reasonably sure about that. You also want to test how finished the unit is as well. So for example, if you're writing something that's just a placeholder and later on you're going to have to put a lot more complicated identity checking in, like maybe you need to start doing things like, oh, if they're in the US, you need to be over the age of 21. If you're in Australia, you need to be over the age of 18, like around drinking laws. If you're just going to have a placeholder in the meantime, it's like, are you over the age of 13? Then putting a lot of effort into building tests for it, if you absolutely know it's going to be replaced, is potentially a bit of a waste of effort. And the other thing as well is the existing test could be quite confusing for new developers, because if a new developer comes along and adds age can't be over 150 because some database admin is complaining about having to store numbers over, I don't know, 1024, they add this new rule that says age can't be over 150, and suddenly they start breaking tests, which can actually make it seem like it's intended that users can be up to the age of 1,000,000. So if you test the edges and a little bit more than that, just to make sure you're not missing something in the middle, you're going to do fairly well. And the other thing you need to do is you need to make sure the tests will fail if something's broken. I know that sounds really, really simple, but you need to challenge your assumptions about what you write, and you need to make sure the test works. Because while I was writing this presentation, with all of these simple examples, there were 4 times I caught myself when I wrote a test and there was no way it could possibly fail. And having to go back and double check that and go, hang on, wait, that's always going to be true. It's actually really easy to write something that looks like it handles everything perfectly and never fails, because it can't fail. All right, here's another one. This is a simple test that just says, if someone puts in their age as -1 years, you tell them to go away. Simple enough. The one problem with this is it doesn't actually say what type of error you're expecting. which in the case of Ruby is actually a big problem, just as an example, because a syntax error is a runtime error. So if you mistyped your code in there in a way that would cause the system to fall over whenever anyone put in an age of -1, your test wouldn't catch that because it's still caught as just some random error. So it's a small little thing. Just make sure that you're careful about what types of errors you're expecting if you're saying this should be throwing an error. Because otherwise your tests could give confidence and mask other issues that someone's now just raised by accident. So the important thing is to test for specific outcomes. You need to have an expectation that, or you need to have strong expectations about the way it should behave in different scenarios. A unit test will only prove that provided inputs meet predefined expectations. So you need to be more specific in this case about the error to make sure you know the right error occurs. If you just expect an error occurred, any particular instance of an error occurring will meet that. And if you don't test enough inputs, you also can't be sure that you're covering what you need to. So, as I said before, syntax error doesn't cause the test to fail rather than pass. You need to ensure you're testing for the outcomes to prove that the right thing is happening. Clearly, I needed a unit test on my slides. If you write a test on the wrong conditions, the test provides no useful information, or even worse, it provides misinformation. Particularly, I like to come back to the example of if I got dropped on a new project, I changed something to meet new business requirements, and suddenly tests start breaking, I'm going to assume I've done the wrong thing, and that can cause people to waste time. Also, all tests have an associated maintenance burden. They're not free. And so a test with no benefit is a net loss in the long run. There's absolutely no way that it benefits the project. All right, for another example, in this one here, we test to make sure that a user can register successfully through one of our units. So we create a time that we expect, we register the user, we overwrite the registration date with that time, and then we compare the values to make sure they all match. It works, but it doesn't care about the registration date. And so it starts comparing things in a really complicated way. It goes, does everything that comes out of this match up to everything that I'm putting here, even if I don't care about some of those values? So if new fields got added to the result of the registration, the test would probably break. Error messages also require the developer to investigate more instead of at least narrowing it down to a single comparison, because all it's saying is these two objects didn't equal, and then you have to start debugging. Why aren't they equal? What's different about them? Is this intended behavior? And so you can simplify it quite a bit just by going, okay, I'm going to produce a result. I'm just going to check the specific parts of that result that are important to me to make sure it's doing the right thing. So I put this information in, I get this information out as a result. Anything else, not in the scope of this test. And so if you use selective comparisons and you keep them up to date, you'll avoid false alarms while still confirming the unit performs the way you expect. And so also selective comparisons are generally easier to read and follow to understand what's going on, what's important in this test. Another code example. So in this here, I've got a fictitious algorithm that produces a win-loss ratio depending on how many games you've won, how many you've lost, and then provides the ratio at the end. Now, the problem here is it's important to test a wide enough range of values to confirm the different parameters perform properly. So, if you look here, I'm changing the wins, not changing the losses at all. So, if dividing by the second parameter, passing a 0 would cause a division by 0 error. So, if you're not actually trying a different range of values, you'd miss something like that. Very easy to write in there, and you just don't consider it. I mean, this is like why QA will produce comprehensive test plans. So let's try this, let's try that. You have to apply the same kind of logic to what you're doing because it's easy to miss something like, oh, I didn't pass through, try passing through zeros for all of these. Oh, I just divided by 0. So basically in this case, I actually did the opposite of what we did previously is I expanded the number of tests, also tried to make it a little more readable, but just testing a few different things like, can I put in zeros for wins and losses? Does that work? Can I try just a different variety of changing them and make sure changing the different parameters relative to each other has the same kind of outputs I'm expecting? And I went a little bit crazy with the Ruby there. But as usual, you want to test appropriately to your domain. You want to make sure you also cover enough different scenarios. So if you're talking about like a high school netball team, you probably don't need to worry about how do they perform with 2,000 wins, 1,000 losses or something like that. It's possibly a bit big for your domain. Not that it really necessarily hurts, but just be a little bit sensible, I guess, about what values you really need to work with. This one here, there's theoretically nothing wrong with the test itself. But if I came into a new project and looked at this here, I'd be having a few words with the BA about, hang on, why can't we use emails with dashes in? Explain, because it's important to explain the purpose of a test with enough context to give the next developer confidence. So the test comment implied that not being able to use dashes in emails is desired behavior, but it's quite silly to assume that they can't have dashes because, I mean, until all of about 6 months ago or something, we all had dashes in our email addresses. You know, it's not an uncommon thing. But having that comment sitting there in the code saying, let's reject dashes, implies that rather than someone writing a test case that handles a bug or something, it implies that actually, hey, we're deliberately not supporting this. And like I talked to people where they had examples of this, like there were issues where, or like there'd be comments around tests. So it was actually a case of, oh, there's some weird behavior with text encoding conversion, but it was actually written in such a way that it made it sound like it was a desired feature. So it's, I mean, I think one of the big points I like to stress is imagine a new developer is coming along and reading this because, and what sort of an image are they going to get? What impression are they going to get about the aspects of the system and the way it should behave? So also something else that helps is giving information with references to points in time. So bugs in Jira can be helpful, provided you don't suddenly move from Jira in future or hand it over to someone else who doesn't have access to it. Also, sometimes just a timestamp can be a little bit helpful. And yes, I know you can use git blame to work out where something is until someone migrates all of it to a new repo or reformats all of the code or something like that. This is something this has actually happened. I'm pretty sure on my current project, anything that hasn't been changed in a while just says blame Liam Dawson. Yeah. So yeah, I became project scapegoat then. All right, and just nearly out of examples, but this one here, the big point is this big wall of text of code is building a whole series of mocks. It says, I expect these method calls, and eventually end up setting up a chain of mocks where one item inside another item inside of another item. And basically all the way down it checks to make sure that all of these different bits and pieces are called in order to reach the final result. But the problem is if you mock everything, you're testing the mocking library. You're not actually testing your own code. So in this instance here, everything that you're calling has already been predefined. Oh, it's going to return this. You're not actually specifically testing any code. Also, it used global variables, which makes testing a lot harder as well, because it makes it more difficult to reason about the state of the application, and also just to overwrite things and inject your own helpers in around testing. It's important to mock as little as possible to achieve confidence in the test. So mocking things that introduce variants to your test system, like databases or network calls, I think is quite important. But at the same time, if you go a little bit overboard with that, you're not actually really getting a good indication of what's going on. So in this instance here, what I did was I found the bottom thing in the hierarchy that actually needs to do anything, or in other words, I just made a fake email provider out of this whole chain of stuff, throw it in at the end, but you otherwise use exactly all of what's there under the hood, because there was nothing special about what I'd written. It was just a case of, I just want to make sure that it finds something that behaves this way. No special logic was needed there, just add a fake parser. That's it. All of the middle bits, just leave them and actually make sure they run and do what they're expected to do. I know that was a bit abstract, sorry. And then this one here, testing unknown email providers, basically comes down to the same thing. There's one mocking call, but quite honestly, there doesn't need to be any, because that test inspires false confidence and it means that it mocks everything again, even though there was only one call. All you're trying to do is just make sure the default behavior of this thing finds an unknown value. Done. So I mean, you might look at it as being a code smell if you come across this huge wall of mocking, like, oh, I'm going to mock this and this and this and make it just behave this particular way under a test environment. But at the same time, even just one little call can actually defeat the purpose of a test anyway. So in this instance, all I did was just tested the thing. So I've made a little bit of an effort to try and distill all of this into a way to think about writing solid unit tests. So just a few foundational points, I guess. The first thing is it's important to understand what you're building. So if you build a code or a test to solve the wrong problem, that's one of the worst possible outcomes because you're leading people down the garden path. It doesn't matter whether you're doing test-driven development or you're just writing tests for existing code. You test for the wrong outcomes, it's actually going to cause more harm than good. And I mean, I've seen this before, like for example, oh, the application already produces these values. I'm just going to throw them into the test. Turns out those values were wrong in the first place. So when we actually fix the bug, tests start failing. Unit testing also cannot ensure business functionality is completely met because that generally happens at a higher level. But if you make the wrong assumptions, it can actually make it harder to reach that. So it can actually combat that. Second thing is join units loosely. So if you start jamming things together tightly and say this thing has to talk to this thing in particular, you're actually just making a bigger unit. Just a super unit, I guess. So bigger units are harder to accurately test. They're harder to debug, and they're also harder to reason about because it's a case of you've now got more moving parts all under one cover. So you can use dependencies like, techniques such as dependency injection to improve loosely coupling these things and therefore improve their testability. It's not the only benefit of dependency injection, but it's definitely a strong one. Test your assumptions. Remember when I said earlier, I wrote code 4 times. I went and wrote tests that couldn't fail and just had to double check it and make sure. So if you can't, make sure it fails if the conditions aren't met. Because you can quite easily end up with tests that quite honestly feel good. It's like, oh, this is a beautiful test, but it actually doesn't do anything. Test responsibly. So don't test something excessively if you know it's going to change. Like if you're putting, I don't know, some dummy user registration in place and you're going to change it in 3 weeks, putting a whole series of tests around that is not an efficient use of time. And also make sure your tests in that instance provide accurate information to other developers. Don't make bugs seem like intended behavior. Coverage is a tool. So whether you're using code coverage via an automated sort of like an automated tool that says, oh, if X% is covered, or whether you're deciding it yourself, it's a great heuristic and can help you find under-tested areas of code. But it doesn't provide any form of proof that things are okay. Learn from mistakes. So if an area of code more frequently experiences bugs, test it more frequently. Put more effort into testing that area. When practical, write a test to prove a bug first. So if you run into a specific issue, write a test that says it shouldn't be doing this, then solve the issue. This has 2 benefits. It can help you find, it'll tell you if the bug reappears again, so a regression of that. And it can also help others learn about this pitfall and make sure that they're not going to run into the same issue. Run them often. The value of a unit test is reliant on how often it's run. So, unless you're writing something really complicated, like you're testing all of the number of functionality in a programming language or something like that, and it's going to take you multiple hours, long tests aren't really tests that people want to run, and the less often people run them, the less useful they are, simplistically. So a fast test that covers most of the functionality is better than the slow test that covers all of it, because unit testing is not the only layer in your strategy. Keeping unit tests fast encourages developers to run them more frequently, and it also imposes less overhead to put them into continuous integration. So if you have these unit tests running every time you save your code, every time you push it, every time you got a PR, constantly appearing all over the place, it can help you avoid simple little mistakes you might otherwise make because you've got the computer, I guess, looking out for you a little. You also need to make sure your tests are reliable. So tests that fail intermittently make it impossible to know how healthy your unit is. They also introduce noise and uncertainty. So particularly with unit tests, most of all, always try to find a way to ensure determinism, because if developers start getting used to things mysteriously failing, they're going to miss something important. So, these are mostly sort of synthesis of ideas I found from other people and a lot of my own thoughts. But unit testing is a powerful way to give developers confidence with what they're working on. It acts as a safeguard against some simple errors and provides orientation for incoming developers. Understanding where it's appropriate to use them is half of your battle. Writing effective tests is the other half. So hopefully I've given people a little bit of an idea today on how to be a little more effective with writing these. Now, any questions? Which I'm checking now. All right. Doesn't look like anyone submitted any questions on the app, but Simon apparently has a question.
When you're faced with the case where you've got existing code that you want to add tests to and it is strongly coupled or otherwise difficult to add tests to, do you take the strategy of prioritizing refactoring it so it can be unit tested, or you just give up on that and look towards some sort of integration level testing or a different form of handling?
Yeah, good question. I suspect a lot of it comes down to part of it does come down to the project, I guess, in general, because I mean, in the perfect world, refactor and put those tests in place, which you would first have to start by making sure you understand how it's meant to behave as your first step. But sometimes it is a little bit, sometimes you have to be really quick. You don't have time to necessarily do great refactoring, depends on budget, all sorts of things. I guess I would say it really does depend. Sometimes the best you can do is just punch things in at a higher level and just kind of pray a little bit, I'm afraid. Do you have a question, Chris?
If you could speak at all to what you think would be a reasonable strategy for adding more unit testing into Cartwheel, I think a lot of it might generalize across other projects. So the context being like a large code base that is not written for unit testing, how to manage the refactor without introducing bugs. Did your travels through the unit testing documentation yield any answers?
I think that one really comes back to the point where I was saying that the point was that you need to really make sure you know what something is supposed to be doing before you start writing tests for it, in case you start writing the wrong tests. So yeah, I mean, if you write the wrong tests, yeah, you're doomed. Yeah. So yeah, it's a case where you have to really step slowly and cautiously to make sure you're not introducing the wrong things. Sometimes it's good to start using some of the techniques around working with legacy code. Like one I'm a fan of is referred to as firewalling, which is where you start sort of isolating a part of the system off by building a layer on top of it. If you can start to build that layer correctly and start integrating the tests to that, you can eventually sort of migrate things into a better state. That's probably something I'd think more on long term when you're dealing with legacy. In those kinds of environments, if you're able to be very sure that you haven't introduced bugs, you can actually start to improve that. But generally, at that point in time, you want to be really good friends with the QA people. I have a question from Todd, which I'll bring up here. So I've read if bug exists, write test for that. Does that cause too much unit bloat, or is that mostly beneficial? And he's added more specifically, if unit tests don't already exist. This one, I guess, can be a little bit of a case-by-case basis. And also there is I think it's a little bit radical, but I have definitely heard a few people say that there's this concept of if a test always passes, delete it, because it's not actually, it hasn't helped you out at all. I think this one, yeah, is kind of, it's a much more of a case-by-case basis because you have to, I guess, evaluate the impact of it and how helpful it is and perhaps take it out later. I think unit tests probably, as a general rule, should be curated every now and then just to make sure you don't have cruft that's not benefiting you at all. But I would say that its benefit mostly comes down to making sure that developers are confident about what they're working on and that they're coming out with the right outcomes. So possibly also depends on a project by project basis. Okay, so okay, yes, and yep, and so Ben's just added as well that it's also a good way to actually ensure that you have fixed the bug, as in if you make the test that fails with the bug and now it passes when you fix the bug, that's a good way of verifying it's actually happened. I would agree that for sort of like application is not behaving as expected bugs, absolutely is good for that. Perhaps not quite so much for like complex interaction business logic and that kind of thing, which might be higher than a unit test level. So also does come down to, I guess, as well, the whole write the unit test if you can, sometimes is not awfully practical. So, okay, Todd, did that answer your question?
Thanks a lot, yeah.
Excellent. Anyone else? Simon.
So throughout the talk, there's been discussion of the idea of being a tension between useless tests and writing tests too early, and also having enough coverage for critical parts of the app. In agile development, presumably the first things you're working on are the most valuable things and may in fact entail being the most critical paths. But at the same time, they're also the first bits of code you write might be the most subject to change over the lifetime of the development. So do you have like a heuristic for when you actually start writing unit tests in that first sort of few weeks maybe of development on, say, a multi-month project or something like that?
Okay, so this is just completely anecdotal. I don't have anything to back this up, but I would say that if you don't write tests, as like if you start off not writing tests, you're not really going to actually do a good job of it from my experience. Even if you're not necessarily writing really, really strong and comprehensive tests from the start, at least making sure you're in the habit of it right from the word go, I think can be important. So like I personally would recommend that as part of their sort of ramp up for a new project. That should be something that's considered as well. Make sure you're going about writing these tests in the right way, and it's something you do as you go along. So you don't need to write anything massively comprehensive right from the start, because as you point out, there can be a lot of change. But I think getting into the habit is probably one of the most important things you can do to make sure it's actually a practice rather than just something you might say you do and kind of pay attention to once every couple of weeks. Okay. So Chris says, as a best practice, should we have passing unit tests sort of just be put into CI right from the word go on a project? I would say that fits in with the idea of getting used to it, making sure it's actually a core part of your workflow rather than an afterthought. So if your pull requests fail because the tests don't pass, it forces you to think about it because you don't have an option. You make the test pass. Anyone else? Simon's thinking.
Yeah, sorry, Liam. Hi, this is Todd.
Yep.
On that last statement you just made, make your tests pass. Is that sort of false information, a false positive?
I think that kind of ties in with the whole code review aspect as well, because you might, I mean, if you make the changes to make the test, so code review also needs to be paying a good amount of attention to tests as well to make sure that people aren't just writing something that says assert true, you know, just make sure it passes as much as a case of, I mean, I don't know. I might almost argue that you should pay slightly more attention to the tests than the actual original code, depending on the context. Because if someone writes the wrong test and it passes, then that might also start giving you information that it's doing the wrong thing. So it is, I guess, part of also of that concept of making sure that you've got appropriate code review in place as well, just as that double check. And also comes down to the whole, okay, make the test pass, but also challenge your assumptions. Make sure it will fail if you're doing the wrong thing.
Okay.
Does that answer your question?
And therefore, I assume that as part of the code review, your peer developer or engineer is also checking your unit tests as well, right?
Absolutely. I think that is utterly critical. As in, like, I think that on a project that's in a really good state with unit testing, valid excuses for a PR not being merged should include not enough tests, or the test is wrong, or basically, I'm not sure that this test is going to perform, I'm not sure this test is proving exactly what we need to prove here. So in that instance, it effectively should be considered as much a first-class citizen as the actual code itself.
Great, thanks.
Alrighty. Doesn't look like anyone else says anything more. Thank you very much.